The function h is given in the piecewise-defined function form. This one is called, let's see, piecewise-defined function. Okay. That means the function is defined based on the condition of the x. One of the applications that we went last week was the phone call charges that are based on like the first 3 minutes is charged with the fixed rate, and then the rest depends on the additional minute. Similar way to see as the application of the piecewise defined function. So for this is just one of the skill problems. The function h is provided as 0 for the x that less than 0. And for 1, h of x equals 1 if x is greater than or equal to 0. And if you want to see in a graphical way, the splitting point would be the 0. So at 0 here, the right hand side will be the side at x greater than 0. The left going to be the side at x less than 0. If you want to put the graphs, the function in a graph form, if x less than 0, not including, the function value is 0. I put a note here. So the h of x or the y gonna be 0. And for x greater than 0, the h of x equals 1. So the graph would look like the straight line as y equals 0 on the left side, not including because strictly less than. For the right hand side, starting from 0, the function gonna be 1 and keep going to the right side of the xy plane. Okay, so you can see the two split graph, and the value depends on the value of the x that's provided. Now, back to the problem. Part A asks for the limit as x approaches 0, negative sign as a superscript. That means coming from the left side of the 0. Okay, negative sign means on from the left. In the mathematical meaning, it means x, whatever the number that we are observing gonna be slightly less than 0 because from the left side. Okay, as for the limit of the function h as x approaches 0 negative. So you just trade the graph. If you have the graph handy, you trade the graph as x approaching 0 from the left side, the function approaching to the value 0, because we do based on the left line or the left graph. So the answer gonna be 0 as the limit value. And then for part B, the limit of the function as x approaches 0 positive, that means from the right side, the value on the right of the x equals 0 can be slightly greater than 0. If it's slightly greater than 0, we can go with the second option or the second graph or the graph on the right side of the xy plane. Now, if we trace the graph from the left or from the right side, as x approaches 0 from the right side, the function approaching to the value 1, okay, equals 1. Now, part A and part B give you the one-sided limit. One value approaches 0, the other value approaches 1. The part C, no superscript. That means we are looking at the two-sided limit. No superscript plus or minus sign. It means you have to look for the common function value that both sides like coming toward to the same number. But for this situation, the left limit not equal to the right hand limit.
DNE.
Right. So our conclusion would be DNE or does not exist. Because we cannot just take one of them. If they don't agree, so we say that it doesn't happen. It doesn't exist. Okay, you just say like DNE. And then the last one, no limit notation. That means we just go back to the function notation itself and then compute the value or find the function value for the particular point for x equals 0. What is the function value? Now you either look at the graph or the piecewise defined function. For the function itself, you look for the option that's cover the x equals 0. The one at x equals 0 would be the second option because x greater than or equals 0. That's including x equals 0. So we go with the function value 1. So that's the answer. And that should be confirmed by the graph that we just drew earlier. H at 0, as you see at the point 0, what the function value right there?
1.
At 1. So they both have to agree. Okay, so this is another situation that you can find the limit, either one-sided limit or two-sided limit, including the function value. And I put it out as to show you the function value can be found for this problem. As you see, the function value can be found. The limit of each side can be found, but the two-sided limit doesn't happen. You see the different situation